Hi everyone, welcome to episode 2 of How Are LLMs Built. We'll dive into the second step, tokenization. Tokenization refers to the process of breaking down a sequence of text into smaller units known as tokens. While basic tokenization simply splits text into tokens based on white space, most advanced tokenization techniques rely on a word dictionary. However, a common issue arises when a word is out of vocabulary. That is, the word is not present in the dictionary, leaving the tokenizer unable to process it. To address this problem, many tokenizers used for LLMs are based on subword tokenization. This approach divides the words into smaller, meaningful units called subwords, which can be recombined to form a vast array of words, including those unseen during training or those in different languages. Here are 3 widely used tokenization methods: Byte Pair Encoding, WordPiece, and SentencePiece. Byte Pair Encoding is an original data compression algorithm that uses frequent patterns at the byte level to compress data. It starts by merging the most frequent pairs of characters or subwords until it reaches a set vocabulary size. For example, say the corpus or training data contains these following words. When tokenizing the word slower, it identifies low as one of the tokens, as it is the most frequent subword in the training data. Now let's dive into the code. There's no fixed number of iterations. It keeps updating the vocabulary during training until it reaches the target vocabulary size or runs out of frequent pairs to merge. After training, when you encode a word, say slower, it provides the tokens it learned during training, and since it's all about frequency, tweaking the min frequency setting can produce different tokens for the same word. Before moving on to the next tokenization technique, let's understand special tokens. These special tokens in LLMs are unique symbols used to manage specific tasks or structure the input data. Tokens like U and K represent out-of-vocabulary words. CLS is used to signify the beginning of a sequence, especially for a classification task. SAP separates different segments of text, such as sentences. PAD pads sequences to ensure uniform length across inputs, and mask is used in masked language modeling tasks, where certain tokens are hidden to predict the missing information. WordPiece is the tokenization algorithm developed by Google to pre-train BERT. The main difference from byte pair encoding lies in how the pairs to be merged are selected. Instead of choosing the most frequent pair, WordPiece merges pairs that maximize the likelihood of the training data when added to the vocabulary. The key difference is the selection criterion for merging. WordPiece computes a score for each pair, calculated by dividing the frequency of the pair by the product of the frequencies of each of its parts. The algorithm prioritizes merging pairs where the individual parts are less frequent in the vocabulary. Let's consider the same corpus we used for byte pair and calculate the score. The score for the subword, say OW, here is 0.2. And the score for the subword low is 0.04. Although low is more frequent, OW has a higher likelihood of being a subword or a suffix based on the training data. In the learned vocabulary, you may notice hashtag symbols indicating suffixes. The final tokens for the example word slower are as follows. SentencePiece does not require pre-tokenization. That is, splitting text into words using spaces. It treats the input as raw sequence of characters, including spaces. Unlike byte pair and WordPiece, SentencePiece treats the input text as a sequence of Unicode characters. Whitespace is handled as a normal symbol. When training a SentencePiece tokenizer, we need to specify the algorithm, say byte pair in this case, on the provided corpus and save the model. After training, the model can encode new sentences directly. For example, say the corpus contains the following sentence: this is slowest. When encoding the sentence "this is slow," it yields the following result. To handle whitespace explicitly, SentencePiece escapes spaces with a meta symbol. The word slow is tokenized as S and low, with low being the most frequent subword in the training data. Here's a comparison table summarizing the key differences between the 3 tokenization algorithms. Thanks for for watching. I hope you enjoyed the video. If you did, don't forget to hit that like button, subscribe and ring the bell so you never miss out on future content. Feel free to leave a comment below with your thoughts or any questions you might have. See you in the next one.